So in this video, we will discuss question number 4. Assertion A. A depth Z below the surface of a submerged soil water pressure is gamma W into Z, and it is the stress caused by the water which is called the neutral stress. Yes, this statement is correct. Okay. The next statement. The water pressure acts equally in all direction. Yes, this up to this is correct. And transmit the same fully transmit the same fully on grain to grain contact using compression in the soil. The water pressure acts equally in all direction and transmit the same fully on grain to grain contact. No, this statement is incorrect. It will not transfer uh, it will not transmit the pressure on the grain. Okay, so for this question answer will be C. Assertion is correct but reason is not correct. So let me explain this. Pore water pressure, about this pore water pressure. Okay, pore pore water pore water pressure. So it is generally denoted by small u. Okay, small u. So pore water pressure, it is the pressure of water. it is it is the pressure of water. It is the pressure of water filling the voids, filling the filling the voids, space between voids, space between soil particle, soil between soil particles. Okay. So if suppose this is the groundwater table and this is saturated soil, saturated soil, and this is dry soil. And let us assume a force F is acting on it. Okay, force F is acting on it. So if the height of this saturated soil sample is H2 and this is dry soil depth is H1, then we have to calculate the effect pore water pressure at this point. Okay, then you have to put a piezometer to find the pore water pressure. You must insert a piezometer. This is piezometer, and this level and here this level and here this level will be same after very long time while F is applied. Okay, so this is after this situation will be after long time, long time, after long time. Okay, so from here u will be the height of water in this piezometer, that is H2. This will be same, this will also H2. So this is u is equal to gamma W into H2, and this is when force F has been acting on, when when force F has been acting on acting on soil soil since long ago, since long ago. Okay, so this will be the pore water pressure, and pore water pressure is also called pore water pressure is also called neutral stress, neutral neutral stress, because it acts on, because it acts on because it acts on all sides of the particle, acts on all sides of the all sides of the particles, but but does not cause, does not but does not cause particles, does not cause particles to press against, to press press against adjacent particle, adjacent particle, adjacent particle. It has no shear component. It has no shear component. Okay. And according to this, the reason R is, the reason R is wrong statement. Reason R is wrong. Okay. The next point about pore water pressure is pore water pressure is measured. Pore water pressure is measured using a piezometer, piezometer or a standpipe, or a stand pipe, and hence pore water pressure is a measurable quantity. Okay, total stress is also a measurable quantity, but effective stress is not a measurable quantity. Okay, pore water pressure is a measurable quantity and it is measured by piezometer. Okay, so this is all about question number 4. Next is question number 5. Question number 5 again, quicksand condition. uh, Quicksand is not a type of sand, but it is a condition arising in the sand marks. Yes, this is correct. This assertion is correct. Now reason: when the upward seepage pressure becomes equal to the pressure due to the submerged weight of soil, the effective pressure becomes zero. Yes, this statement also correct, and this is the correct explanation of assertion A. Okay, so answer will be A, and we already explained. We have already explained this in question number 1. Okay, so already explained in question number 1. Okay, so this is all about question number 5. Now question number 6. An upward hydraulic gradient I of a certain magnitude will initiate the phenomena of boiling in granular soils. The magnitude of this gradient is, the magnitude is approximately 1, and it may be greater than 1. So this statement, this option is wrong. This is also wrong, and this is not less than 2. It is greater than, it may be greater than 1, but not less than 2. So this also wrong. This will be the correct option. So C will be correct option. This is also explained in question number 1. Okay, it is also explained in question number 1. Let me show you in question number 1. uh, Question number 1 here. Okay, ICR is equal to 1. For usual range of void ratio, E is equal to 0.6 to 0.7 in a sand, and with specific gravity of GS is equal to 2.75, ICR is equal to approximately equal to 1. So this is the answer for question number 5. Okay, so Now question number 6 is done. Now question number 7. Question number 7. A deposit of fine sand has a porosity N and a specific gravity of soil solid is G. The hydraulic gradient of the deposit to develop boiling condition of sand is given by. Again, this is explained in question number 1. And you know that IC is equal to G minus 1 divided by 1 plus E. Okay. And in this case, porosity is N. So E is equal to porosity divided by 1 minus porosity. Put this value of E in IC and you will get IC is equal to G minus 1 divided by 1 plus E, that is N divided by 1 minus N. Okay, so this is G minus 1 minus N, that is 1 minus N plus N, and get cancel out, and you will have G minus 1 into 1 minus N. So IC is equal to G minus 1 into 1 minus N. So answer will be A. Question number 7, answer will be A. Okay. Now question number 8. A bed of sand consists of three horizontal layers of equal thickness. The value of Darcy is K for the upper and the lower layer is this one, and that for the middle layer is this. The ratio of the permeability of the bed in the horizontal direction to that in the vertical direction. Okay, so if this is the layer, okay, so this is the K value for this is 1 into 10 to the power minus 2 centimeter per second, and this is K1. Suppose K2 is equal to 1 into 10 to the power minus 1 centimeter per second, and K3 is 1 into 10 to the minus 2 centimeter per second. Now we have to calculate K horizontal and K vertical. So formula for K horizontal is equal to K1 H1 plus K2 H2 plus K3 H3 divided by H1 plus H2 plus H3. And similarly, the formula for Kv is equal to H1 plus H2 plus H3 divided by H1 by K1 plus H2 by K2 plus H3 by K3. So if you calculate both the expression, then K1 is 1 into 10 to the power minus 2 and the thickness is same. So let us take thickness as H, plus K2 is 1 into 10 to the power minus 1 into also H, plus K3 is 1 into 10 to the power minus 2 into H divided by H plus H plus H, that is 3H. Okay. So when we calculate this expression, we will get 1 upon 25. And when you calculate this is H plus H plus H divided by H by K1, 1 into 10 to the power minus 2, plus H by K2, 1 into 10 to the power minus 1, plus H by K3, 1 into 10 to the power minus 2. And this will be 3 upon, when you calculate this, you will get 3 upon 210. So from here K1, from here uh, we have to calculate ratio of permeability of bed in horizontal direction to that of vertical. So we have to calculate Kh by Kv. So Kh is 1 upon 25 into 210 by 3. Okay, 1 upon 25 into 210 by 3. Then this will be 14 by 5. This is 2.8. So 2.8 by 1. So this is 2.8 is to 1. So B will be the answer for this question. This the important formula is this. Just remember this formula. Very important formula. In many exams, it will be asked like AED exams and UPSC. This is this may be asked. Okay, very important formula. So next is question number 9. So in question number 9, due to rise in temperature, the viscosity and the unit weight of percolating fluid are reduced to 70% and 90% respectively. Other things being constant, the change in coefficient of permeability will be. Okay, so you know that permeability K is equal to gamma W, uh, gamma W by mu EQ divided by 1 plus E 1 upon K. This is some constant into specific surface area whole square. This is K. So actually, if other thing is constant and gamma W and mu is changing only, then I'm taking this whole as a constant. So K is some constant C into gamma W by mu. So now if percolating fluid are reduced to viscosity and unit weight of percolating fluid are reduced to 70%, so K prime is equal to C times uh, viscosity is reduced to 70% and gamma W is reduced to 90%. So this is 0.9 gamma W by 0.7 mu. Okay, this is K prime. So the change in coefficient of permeability. So change in coefficient of permeability will be change in coefficient of permeability delta K is equal to K prime K prime minus K prime minus K. Okay, so this is K prime is uh, K prime minus K by K. So K prime is um, this is 0.9 gamma W by 0.7 mu C into this minus C into gamma W by mu divided by this is me C into gamma W by mu. So this will get cancel out. Okay, so this is 9 by 7 minus 1. So this is 7. 9 minus 7, that is 2 by 7. This is 2 by 7. This is 28.57%. Okay, so answer will be B. This is very important question. Okay, so in this expression, let me explain about every term. Here in this expression, that is K is equal to gamma W by mu EQ divided by 1 plus E 1 upon KK surface area square, specific surface area whole square. This is specific surface area. Okay, so here E is equal to what? E is equal to Y ratio. E is equal to Y ratio. So permeability also depend on Y ratio and it is directly proportional to Y ratio actually. Okay, as water increases, E will increase. And gamma W is equal to unit weight of liquid. Unit weight of liquid. Unit weight of liquid. That is unit weight of liquid. Okay. And mu is dynamic viscosity. Dynamic viscosity. And as temperature increases, mu will decrease. As temperature increases, mu will decrease, and therefore K will increase. Just remember this point. This is very important point. Okay, because viscosity will have the greater change as compared to gamma W. When temperature increases, gamma W also may increase or decrease. Okay, increase, the gamma W will be maximum at 4 degrees Celsius, but change in gamma W as compared to change in mu as temperature increases is less. Okay, so change in viscosity will be more as compared to change in gamma W, unit weight of water, when temperature changes. Okay, so as temperature increases, viscosity will decrease and permeability will increase. So this is a very important point. Just keep in mind. Okay, and SA is a specific surface area, a specific surface area, and KK is Cosny constant. Cosny constant. That is, it is a safe factor, a safe, a safe factor that accounts for that that accounts for that account for the the tortuosity, tortuosity, the winding path, the binding, the binding path of the pores of the pores. Okay, so these are very important points. Just keep these points in mind, and this is very important. Okay, I'm making star on this because this is very important for any exam. This is very important for any exam like AE, JE, and uh, exam like UPSC. This is previous year question. Okay, so ESE, previous year question we are discussing here. Okay, this is very important. So question number we will discuss now. Question number 10. So assertion is constant head permeability test is not used for fine grained soils. So for fine grained soils, it is used falling head test. So this statement is correct. Okay. So falling head, falling head or variable head, falling head or variable head. Okay. Falling head or variable head. Let me take this. Falling head slash variable head quality test is done for is done for fine grained soil. Fine fine grained soil. Okay. And next, falling slash variable. Okay. And constant head, constant permeability test is done for coarse grained soil. Coarse grained, coarse grained soil like like sand. Okay, so this statement is correct. Now the second statement is reason is the lesser the permeability of the soil, lesser is the discharge. The lesser is the permeability, the lesser is the discharge. Yes, this statement is correct. And because of this, constant head permeability test is not used for fine grained soil. Okay, so because in fine grained soil permeability is very less, so we will have discharge. Uh, we will have very little discharge, and that's why we will not use constant head permeability test for fine grained soil. So for question number 10, the answer will be A. Assertion is correct. Reason is also correct. And reason is the correct explanation of assertion A. Okay. So this is question number 10. Okay. So let me write some points regarding this question. So constant head probability test, constant head constant head probability test is not used for is not used for fine grained soil, fine grained fine grained soil because these soil have less these soil have less permeability, less permeability. So accurate measurement of discharge. So accurate measurement of discharge. Accurate measurement of discharge is very difficult. Is very very difficult. So in falling head, falling head, falling head, falling head probability test is used for coarse um, sorry for fine grained soil, for 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 fine grained fine grained soil. And in this case, k is equal to L into A divided by T into A, uh, ln H1 by H2. We already have discussed this in previous question. Okay, somewhere previous question we have discussed this. Okay, and this is also 2.303 La divided by Ta log H1 by H2. Okay, log H1 by H2. And constant head permeability test is used for coarse grained soil, and constant head permeability test is used for coarse grained coarse grained soil. And in this case, K is given by L into volume divided by T H into A. This is the permeability in this case. Okay, and these two tests are lab test. Are lab test. Okay. So now we will discuss question number 11. Now question number 11 is which one of the following equation correctly give the relation between the specific gravity of grain G and the hydraulic gradient I to initiate quick condition in a sand having a wire ratio 0.5. So you know I is equal to G minus 1 divided by 1 plus E. So wire ratio is 0.5. So G minus 1 divided by 1 plus 0.5 is equal to G minus 1 divided by 1.5. So this is 1.5 I. 1.5 I is equal to G minus 1. So from here G is equal to 1 plus 1 plus 1.5 I. The option C will be the answer. So 11, option C will be the answer. Very simple. Discussed question number 1. It is discussed in question number 1. Okay. This is all about question number 11. Now question number 12. Question number 12 is a sand deposit has porosity of 1 by 3. So porosity is 1 by 3 and its specific gravity G is 2.5. The critical hydraulic gradient to cause sand boiling in the stratum will be. So from here first we will calculate E. So E is equal to N divided by 1 minus, and so this is 1 by 3 divided by 1 minus 1 by 3. So this is 1 by 3 and 3, 3 minus 1. So 1 by 3 into 3 by 2. This is 1 by 2. This is 0.5. So E is equal to 0.5. So from here I is equal to G minus 1 divided by 1 plus E. So G is 2.5. 2.5 minus 1 divided by 1 plus 0.5. This is 1.5 divided by 1.5 is equal to 1. So answer will be C. This is all about question number 12. Now question number 13. Consider consider the following statements. Consider the following statements. Constant head permeameter. Constant head permeameter. Uh, constant head permeameter is best suited for determination of coefficient of permeability of highly impermeable soils. Highly impermeable soils. Constant head. Constant head for coarse grain. So statement 1 is wrong. Highly impermeable soil means that is very fine soils like clays. And for this type of soil, we use um, variable head permeability test. Okay. So in this case, we will not use constant head. So statement 1 is wrong. Statement 2, coefficient of permeability of a soil mass decreases with increase in viscosity of pore fluid. So according to this relation, that is K is directly proportional to gamma W by, I'm writing the expression again. Actually, we have discussed this in previous question, but I am writing this again because this is very important. So K is equal to uh, gamma W by mu EQ divided by 1 plus E, and that is 1 upon KK specific surface area square. So this is actually K is directly proportional to gamma W by mu. So as temperature increases, in this case soil mass decreases with increase, coefficient probability of soil mass decreases with increase in viscosity. So as viscosity increases, this implies that permeability will decrease. So this statement is correct one. Okay. Now coefficient of permeability of soil mass increases with increase in temperature of the fluid. As temperature of fluid increases, as temperature of fluid increases, this implies that viscosity will decrease. And as viscosity will decrease, this implies that permeability will increase. Permeability will increase. So as temperature increases, permeability will increase. Okay. So um, coefficient permeability of soil mass increases with increase. So this statement is correct. So 2 and 3 is correct. 2 and 3 is correct, and 1 is wrong. So option C will be the answer. Okay. Answer C will be the answer for this question. So In this through this question, we will try to understand uh, how permeability depends on other factors like particle size, effect of void ratio, effect of permeant like its viscosity and temperature, and shape of the particle, and degree of saturation, effect of soil fabric, impurities in water, and effect of absorbed cations on clay minerals. Okay, on clay minerals, and effect of effective stresses. So on these parameters, the permeability of soil will depend. So it is not only the property of soil, but it also depends on other factor also. So let me discuss this in detail, that how soil behaves, okay, how soil's permeability changes or affects by other factors. So first, um, let me write this: factors, factors, factors affecting, factor affecting permeability, factors affecting, factors affecting permeability. So first factor is particle size. Particle First factor is particle size. Okay. First factor is particle size. So the the coefficient of per coefficient of permeability of a of a soil is proportional to is proportional to the square proportional to the proportional to the square of a representative particle size, square of a re, representative particle size, particle representative particle size. Okay, empirical formula was proposed by Ellen Hazen, and empirical formula was proposed by proposed by Ellen Hazen. Ellen Hazen. Ellen Hazen. That is, K is equal to C d10 square. That is effective size of particle. Okay. So K, where K is permeability of soil, per permeability of soil in centimeter per second, in centimeter per second, and d10 is effective size of particle in mm. Effective size of particle in mm. Okay. An approximate and an approximate equation an approximate equation K is equal to 100 d10 square is is sometimes used sometimes used where K and d10 are in, where where K and d10 are in centimeter per second and centimeter respectively, and centimeter respectively. Okay. So This is uh, the effect of particle size on permeability. So now, um, second is second is effect of wide ratio. Second is effect of wide ratio. Second is effect of effect of wide effect of wide ratio. Second is effect of wide ratio. So according to according to according to Taylor, according to Taylor, K is directly proportional to EQ divided by 1 plus E. So K is equal to some constant times EQ divided by 1 plus E. And C is what? Safe factor. Safe factor. Now now third is effect of permeant. Effect of permeant. That is viscosity and temperature. That is viscosity and temperature. So K is in this case K is directly proportional to gamma upon mu. It should be noted that K is more affected by, it should be, this is very important point. It it should be noted, it should be noted that K is more affected. K is more affected. K is more affected. K is more affected by changing, more affected by change in viscosity, change in viscosity, then change in unit weight, then then change in unit, then change in unit weight, because unit weight of water does not change, because unit weight of water does not unit weight of water does not change much over large range of temperature, over large range of temperature, and therefore K1 by K2 is equal to is equal to uh, mu2 by mu1, according to according to IS 2720 part 17 permeability of soil cell, permeability of soil cell be expressed at 27 degrees Celsius. At 27 degrees Celsius, this temperature is very important. In some exam, it is asked frequently. Okay, so it is reported at 27 degrees Celsius. So K27 is equal to mu at any temperature T divided by mu 27 into K at any temperature T. Okay, so permeability is reported at 27 degrees Celsius. So this is the effect of permeate. Okay. So this is effect of permeability. Okay. So next is fourth one, and that is shape of particle. Okay. That is fourth one, and shape of particle. So next one is shape of particle. Fourth one, that is shape of particle. So that is permeability of soil is permeability of soil is inversely proportional to the square of to the square of a specific surface area, to the square of a specific surface area. K is equal to 1 upon a square. Okay. So for the same wide ratio, 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 the soil with angular particles, the soil with angular particle, soil with angular particle, soil with angular particle are less permeable, are less per are less permeable than than those with those with rounded particle rounded particle than those with rounded particles, as angular particle have greater specific as angular angular particle have greater specific have greater specific surface surface area in in comparison to in comparison to rounded particle rounded rounded particles. Okay. in natural deposit in natural deposit the wire ratio for the wire ratio for a soil for a soil with angular particle angular particle may be greater than that for maybe maybe greater than that for rounded particle that for rounded rounded particles, and the soil with angular particle may be acting more permeable, and soil with angular particle angular particle angular particles may be may be actually more permeable, maybe more, maybe more permeable. Now next is degree of saturation. So next is degree of saturation. Fifth one, degree of saturation. Next is degree of saturation. The permeability of partially saturated soil. The permeability of partially saturated soil is is less than that of fully saturated soil, less than that of fully saturated soil. Okay, the permeability of partially saturated soil is less than that of fully saturated soil. Okay, so also saturation may also impact the permeability. Okay, now sixth one is effect of soil fabric. Effect of soil fabric. Effect of soil fabric. So two clays at same wide ratio, two clays at same wide, two clays at same wide ratio, one having dispersed structure, one having dispersed, dispersed, one having dispersed structure, and and other having flocculated structure, other having flocculated, other having flocculated structure, have different, have different, have different permeability, have different permeability. Okay. And the next point is dispersion causes permeability to dispersion, dispersion that is dispersed structure, in dispersed structure, that is in dispersed soil structure, dispersion causes permeability to decrease, to permeability to decrease basically because basically because of reduction, because of reduction in size of reduction in size of wide available wide available for flow, for flow. Okay, so this is effect of soil fabric on soil's permeability. So next is impurity in water. Seventh one is impurity in water. Seventh is impurity in water. Impurity in water. In impurity in water. So any foreign matter, any foreign matter, foreign any foreign matter in water, in water has a tendency has a has a tendency to plug the flow passes the flow passes the flow passes and reduce the effective and reduced reduce not reduced reduce the effective void, and and hence the permeability of soil decreases, and hence the permeability of soil decreases. Okay, so this is 7, impurity in water. It also affects permeability. Now eighth one is effect of adsorbed cation on clay mineral. Effect of adsorbed cation on clay mineral clay mineral surface clay mineral surface. Okay, so depending on the type of cation, depending depending on the type of cation adsorbed on surface adsorbed on surface adsorbed on surface of montmorillonite 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 clay mineral clay mineral clay mineral permeability increases permeability permeability increases in the following fashion in the following fashion following fashion K plus is less than Na plus less than H plus is less than Ca 2 plus. Similarly for similarly similarly for kyanite kyanite mineral that is Na plus K plus H plus. Okay, this is the effect of adsorption on clay mineral. Okay, this also impact permeability. So in note point, it's very important. Sodium clay, sodium sodium clay have a smaller permeability, have a smaller permeability. Hence in clay core, hence in clay core of earthen dam of earthen dam, soil is treated with soil is treated with salt water to inhibit seepage. Salt water to inhibit seepage. Inhibit seepage. Okay. So the next one is ninth and effect of effective stress. Effect of effective stress. Effect of ninth one is effect of effective stress. Effect of effective stress. Yeah. So as effective stress increases, as effective stress, as effective stress increases, wide ratio decreases. Wide ratio, wide ratio decreases, and consequently permeability decreases, and consequently, consequently permeability decreases. Consequently, permeability decreases. Okay, so k k greater than 10 to the power minus 3 mm, determines by constant head, is centimeter per second, determined by constant head method, constant head constant head method, k less than 10 to the power minus 3 and greater than 10 to the power minus 7 centimeter per second, determined by falling head method, and k less than 10 to the minus 7 per second consolidation formula, determined by consolidation consolidation formula. What is consolidation formula? K is equal to CV MV gamma W. What is CV? CV is nothing but coefficient of consolidation. Coefficient of coefficient of consolidation in centimeter square per second, and MV is coefficient of coefficient of volume coefficient of volume compressibility. It is centimeter square per Newton. Centimeter square per Newton. That is MB. And MB is equal to AB divided by 1 plus E naught. AB is coefficient of compressibility, where AB is coefficient of compressibility. Okay, and AV is writing here. AV is equal to delta A divided by delta sigma. Okay, and if you draw the graph for this, that is E y ratio versus sigma, it will look like this. Okay, that is sigma 1 E1 sigma 2 E2. Okay, so AV is equal to delta EY delta sigma. It is active stress, active stress. Okay, and if you take on log scale, that is E, that is log sigma, the graph will be a straight line, and the slope of this graph represented by CC is equal to delta E divided by log of sigma 1 by sigma 2. This is active stress, sigma 1 by sigma 2, and this is called compression index. Compression compression index. Okay, so This is all about parameters which affects the permeability. Okay. So next is coefficient of permeability by indirect method. To find coefficient of permeability by indirect method. First is Cosny carbon equation. Cosny carbon equation. And this is K is equal to 1 by Cs gamma W by mu 1 upon SS square if you divided by 1 plus U. Same formula. Okay. Second is ln has in formula. ln has in ln has in formula. Is K is equal to C d10 square. And third is consolidation equation. Consolidation equation is K is equal to CV MB gamma. Okay. CV is coefficient of consolidation. Coefficient of consolidation. MB is equal to coefficient of volume compressibility of coefficient of volume compressibility, and MB is equal to AB divided by 1 plus E naught, and AB is equal to coefficient of compressibility. And this is delta E by delta sigma. Okay. This is all about question number 13. Now, question number 14. Question number 14. A strata of 3.5 meter thick fine sand has a void ratio of 0.7 and G is equal to 2.7. For a quicksand condition to develop in this strata, the water flowing in upward direction would require a head of. So you know that IC is equal to G minus 1 divided by 1 plus E. And IC is H upon capital H, that is head causing flow divided by length of flow is equal to G minus 1 divided by 1 plus E. This is H divided by capital H is 3.5 in this question. G is 2.7 minus 1 divided by 1 plus E is 0.7. So this is H upon 3.5 is equal to 1.7 by 1.7. So H is equal to 3.5 meter. So option number D will be the answer. Okay. So we will stop uh, our discussion here. From question number 15, we will discuss in next videos. Okay. Question number 15, we will discuss in next videos on question number 15. Okay. Thank you. Thank you, everyone.